All right, so Air Math Magicians, let's take a gander here. When we are solving, today as we see, we are going to be solving absolute value inequalities. Remember, inequalities, going to be less than or greater than symbols, or they're corresponding with the equal. So it's anything that is absolute value, so it has the absolute value bars, and it has any of these symbols here. So we're going to show you the steps. The steps are almost exactly the same as yesterday. In fact, 1, 2, 3, and 4 are the same. It's the A and the B that are slightly different. That'd be French for different. So, isolate. What are we going to isolate? Oh, shock and awe. We're going to isolate the absolute value. I know, crazy. We're going to isolate the absolute value symbol. Generally, that's going to be on the left side, so just the bars, nothing left. Now, we can do the heartbreaking damage of splitting. And it will split into two inequalities. And just like we did yesterday, one of them will be positive and one of them will be negative. However, we do have to pay attention to what the specific symbols mean. If you have a greater than or equal to symbol, greater, you're going to use the word or. If you have a less than or equal to symbol, you're going to use the word and. It might be a little bit hard to understand why right now, but we'll see it especially on a graph of how the or and the and are radically different. Okay. Ultimately we're going to solve each inequality using the rules of inequality, where sometimes we have to flip the symbol. Sometimes we're going to keep the symbols all the same depending on the situation. And then we're going to check a solution. Why A? Because you're going to have an infinite number of solutions. We just want to check one, maybe two. And if you have time, maybe 77. So I want to point out that when we make the other side negative, we are going to have to flip a symbol. In a moment, we'll see that. We're going to have to flip the inequality symbol. So that will happen only once, unless we multiply or divide by negative. Okay. So on example number 3, we are going to solve this inequality. So step number 1 says isolate the absolute value. Bing! It's already done for me. So I don't have anything more to do, except I'm going to split. So when I split it, it looks like this. You just drop the bars, so you get y minus 5 is less than or equal to 2. Now I'm going to rewrite it, y minus 5, but instead of a positive 2, I change it to a negative 2. And remember back in the old days of solving inequalities, whenever we multiply or divide by a negative, we have to flip the symbol. So that means my symbol here has to be flipped as well. So notice the two changes there. Not only did I make the 2 negative, I also flipped the direction of my inequality. Now what word are we going to use in here? Well, let's see. Here it says if I have a less than symbol, which is what I have right there. Since I have a less than symbol here, I'm going to use the word and. Again, we'll see why that's important, especially when we graph. All right, step 3 is to solve everything individually, so I will add 5, and it turns out that I'm going to add 5 all across the board, not only here and here, but also on the other inequality as well. And so we end up with this. Y is less than or equal to 7, and y is greater than or equal to 3. So let's see how that affects my graph. What we're doing is saying all the numbers that are greater than or equal to 3, so remember, greater than or equal to means it's going to be a closed point at 3, but it's greater than. However, for the y is less than or equal to 7, it's also a closed point because of the equal to, and it's less than 7. However, since I use the word and, both of these have to happen at the exact same time. So in other words, we're choosing any number that is greater than 3, but less than 7. So what would be an example of that? It would be 5 or 6 works, but what doesn't work?
2.
2 does not work. You're right.
Did you just change that to a lightsaber?
Maybe.
Why did you do that?
Let's go ahead and check this with one that we expect. Notice we expect all of this inside here to be true. Whenever I plug in a 4 or a 5 or a 5.5, I expect a true statement. If I plugged in anything over here, I would expect a false statement. And the same thing over here. I would expect anything over here to be false. If I plugged a 10 in, I would get something like 10 equals 12, and that's wrong. So let me just test something that works. So let's try a 5. So instead of putting a y in, let's put a 5 in. I just coincidentally chose 5 there. That minus 5 was just part of the original equation. So I'm testing this. The absolute value of 0 is less than or equal to 2. So 0 is less than, oh, great. It does indeed work. So at least I know that I'm on the right track. The check does not prove 100% that I'm right. It just proves that I'm probably right. Now let's upgrade to a more complex, tell me why'd you have to go and make things? So what we're going to do is the same steps. Number 1, we're going to isolate the variable, or isolate the absolute value. Tell your neighbor, what are the 2 things that need to be gotten rid of? Go. So we have to get rid of that 4. So let me start off with that. Menos cuatro from losi dosi lados. Okay, and we get this. Bring down the negative. Bring down the absolute value. Now the symbol stays the same. I haven't flipped anything. And I bring down a negative 15. But what now needs to happen? Well, if you remember, to get rid of a negative, we have to do this. Divide by a negative 1. And whenever I divide by a negative, beep, 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 beep. Whoa, Nelly.
Nina, you asked me a question.
We have to switch that. The symbol has to switch directions. So, now I have the absolute value all by its lonesome. The symbol is switched direction, and I have a positive 15 on the other side. It's okay if you had a negative on this side, because with absolute value, or excuse me, greater than or less than, there's not as many restrictions as with equal sign. Okay, so now we're in the position to do the splits. So I'm going to say the f minus the 7, greater than or equal to 15. F minus 7, switch directions, make a negative, keep the 15. And what word do we use in between? Greater than, so let's use an or in between. Again, in a moment we'll see why the or is importante. Now I'm going to solve everything by adding 7 to both sides, bring down the or. And now I'm going to add 7 over here, beep, bloop, bleep, to get negativo ocho. Okay. Now let's graph this. You could worry about scale if you want. So if I put down a negative 8 right here, somewhere here, and I count by 2s, I don't even know if I'll be able to get to it, counting by 2s. So I would need to get negative 6, negative 4, negative, so let me do that, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. Still not big enough. So what I'm just going to do is be fairly arbitrary about it. I'm not going to worry about the scale. I'm just going to throw a 22 right there. I don't know what the scale is. Okay, we are going to use closed points at both of these because of the equal to. But what happens? Which way do I shade for the 22? Boom, like a this. And then the -8 is going to shade, boom, like this. So generally, 99% of the time, whenever you see the word or, you're going to see a split like that. 99% of the time, when you see the word and, you're going to see two things unified together like that. So, when would it actually apply? Let me just think about real quick when the word and when the word or is used in real life. You don't have to write this down. We're just going to talk about it real quick. Let's say you want to go to a place like Dismal Land or Knott's Berry Farm or Six Flags, something or another. And you go, or Canopy Lake. Isn't there a place called Canopy Lake? Yeah. Okay. And if your age, if you are under 12 years of age, let's just pretend you pay $30. Just making it up. So, but some other people besides young folk get discounts. Who else?
Senior citizens.
Senior citizens. So it might be a situation where you are greater than or equal to 60, you also pay $30. Can a person be both under 12 and over 60 at the same time? No. No, so we have to use the word or here. It's one or the other. However, there's another set of people whose age is greater than or equal to 12 and they are less than 60. And let's pretend they pay $45. Is it possible for a person to be over 12 and under 60 at the same time?
Yeah.
What would be an example?
45.
A 45-year-old kid.
23.
A 45-year-old kid who lives with his mom in the basement, right? Okay.
Wow. 23 is a little more.
That was really good.
So, notice that the word and the word or are extremely important in the right contexts.